Imagine waking tomorrow morning to discover that your day has become 23 hours long instead of 24. The change is so subtle at first that you might not even notice. Your coffee still steams in the morning light. Birds still sing from their perches, and the world continues its ancient dance around the sun. But something fundamental has shifted beneath your feet. Our planet, this blue marble that has spun at the same steady pace for billions of years, has begun to turn a little faster. This is not science fiction, but a thought experiment that reveals the delicate balance upon which all life depends. Every morning when you step outside, you're standing on the surface of a sphere traveling through space at over 1,000 miles per hour. Right now, as you listen to these words, the ground beneath you is moving faster than the speed of sound, carrying you eastward in an endless rotation. This rotation has remained remarkably constant since before the first humans walked upright. The Earth completes one full rotation every 24 hours, a rhythm so dependable that we've built our entire understanding of time around it. But what would happen if this cosmic metronome began to quicken its beat? What forces would awaken, what patterns would shift, and how would the intricate web of life respond to such a fundamental change? To understand this possibility, we must first appreciate the elegance of our current situation. Picture yourself standing at the equator, perhaps on a pristine beach in Ecuador, where the morning sun rises over endless ocean. Here, you're moving eastward at roughly 1,040 miles per hour, though you feel nothing of this tremendous speed. The atmosphere moves with you, the oceans flow in harmony with your motion, and gravity holds everything in perfect balance. This speed decreases as you travel toward either pole, until at the very top and bottom of our world, the rotational velocity approaches zero. This variation in speed across the Earth's surface creates the gentle curves of wind patterns we know so well. The trade winds that once carried sailing ships across vast oceans exist because of this perfect spin. The seasonal monsoons that bring life-giving rain to billions of people flow in harmony with our rotation. The jet streams that modern aircraft ride across continents are born from this delicate balance. All of these exist because our planet spins at just the right speed to create predictable, life-sustaining patterns. Now imagine that this speed begins to increase, perhaps by just 1% at first, reducing our day from 24 hours to about 23 hours and 45 minutes. The change seems almost negligible, but the effects would ripple outward like waves from a stone dropped into still water. As the Earth spins faster, the centrifugal force that already tugs gently at everything on our planet's surface would grow stronger. Right now, this force is barely noticeable, reducing your weight by only about 0.5% compared to what it would be on a non-rotating Earth. But as the rotation quickens, this outward pull would become more pronounced, particularly near the equator where the rotational speed is greatest. The oceans would be among the first to respond to this change. Water, always seeking its own level, would begin to redistribute itself across the planet's surface. The equatorial bulge that already exists, a slight widening at our planet's middle caused by centrifugal force, would become more pronounced. Coastlines that have remained stable for thousands of years would find themselves submerged as ocean water flows toward the equator. Regions near the poles might see their harbors drain away as water abandons these slower-moving latitudes. Consider the ancient port cities that have stood as gateways between land and sea for millennia. Venice, with its intricate network of canals, might find itself even deeper underwater than the gradual sea level rise already threatens. Meanwhile, coastal cities in northern Canada or Siberia could watch their harbors become landlocked as the ocean retreats toward the equator. They would see vast mudflats where ships once sailed. The atmosphere, too, would respond to this change, though more gradually than the oceans. Air, being less dense than water, would take longer to redistribute, but the effects would be no less dramatic. The jet streams that circle our planet at high altitudes would shift their paths as they increased. Rotation alters the pressure gradients that guide them. Weather patterns that have remained consistent for centuries might begin to wander. bringing rain to deserts and drought to rainforests. Meanwhile, in the world's major cities, engineers and scientists would begin to notice subtler changes. The Coriolis effect, that gentle deflection that causes hurricanes to spin counterclockwise in the northern hemisphere and clockwise in the south, would strengthen. This might seem like a minor adjustment, but it would alter the paths of storms, the flow of rivers, and even the trajectory of long-range artillery shells or spacecraft launches. As the days passed and the Earth's rotation continued to accelerate, more dramatic changes would unfold. If the day shortened to just 20 hours, the increased centrifugal force would begin to have profound effects on the planet's shape itself. Our world is not a perfect sphere, but rather an oblate spheroid, slightly flattened at the poles and bulged at the equator. This shape exists in delicate balance with our current rate of rotation, but as the spin increases, the planet would begin to deform further. The solid rock beneath our feet, which seems so permanent and immovable, would actually begin to flow and adjust to the new forces acting upon it. This process would unfold over geological timescales, but the initial adjustments might manifest as increased seismic activity. Fault lines that have remained quiet for centuries might stir to life as the Earth's crust adapts to its changing shape. Not far from where this story of acceleration began, deep within the Earth's core, the molten metal that generates our planet's magnetic field would also respond to the change. The magnetic field that protects us from harmful solar radiation and makes compass navigation possible exists because of complex interactions between the Earth's rotation and the movement of liquid iron in its core. A faster spin would alter these dynamics in ways that scientists are only beginning to understand through computer simulations. As the acceleration continued, reducing our day to perhaps 18 hours, the effects on living things would become impossible to ignore. Plants, which have evolved their growth patterns around the steady rhythm of day and night, might struggle to adapt. The internal clocks that govern when flowers open, when leaves unfurl, and when trees prepare for seasonal changes are all calibrated to our current 24-hour cycle. Animals, too, would face unprecedented challenges. Migration patterns that have remained constant for thousands of years might falter as the magnetic field shifts and familiar landmarks disappear beneath rising equatorial seas. The delicate timing that brings predators and prey together would be thrown into chaos. The synchronization that times breeding seasons with favorable conditions would break down. The guides that lead countless species through their daily routines would become unreliable. Yet life on Earth has survived dramatic changes before. The fossil record tells of creatures that adapted to ice ages, massive volcanic eruptions, and even asteroid impacts. Given enough time, evolution might find ways to adjust to a faster spinning world, though the cost and extinctions could be enormous. As we push this thought experiment further, imagining our day shortened to just 12 hours, the changes would become truly dramatic. The increased centrifugal force would now be strong enough to noticeably reduce your weight, particularly if you lived near the equator. Walking would feel different, jumping would carry you higher, and the simple act of dropping an object would seem subtly altered as it falls more slowly toward the ground. The oceans, now distributed in a much more pronounced equatorial bulge, would have created vast new seas around the middle of our planet. The polar regions would be left largely dry as water flows toward the equator. The familiar outlines of continents would be unrecognizable as coastal plains disappeared beneath the waves. New landmasses would emerge where deep ocean once lay. Weather patterns would have reorganized completely. The trade winds would blow with unprecedented fury, creating storms of incredible intensity around the equator. The polar regions would be left eerily calm as the fast-moving air masses abandoned these slower latitudes. The temperature differences between these regions would become more extreme, as the fast-moving equatorial areas generated more heat through friction. The slower poles would cool in the absence of warm ocean currents. Even more dramatically, if we imagine our planet spinning fast enough to reduce the day to just 6 hours, we would approach what scientists call the breakup limit. At this point, the centrifugal force would become so strong that material at the equator would begin to escape the planet's gravitational hold. Rocks, soil, and eventually entire chunks of the Earth's surface would be flung into space. This would create a ring system around our planet, much like those found around Saturn. This is not mere speculation, but a phenomenon that astronomers have observed around other celestial bodies. Some asteroids spin so rapidly that they continuously shed material, creating trailing clouds of debris that follow them through space. If Earth were to reach such speeds, we would transform from a solid world into something resembling a cosmic hurricane. We would become a dense core surrounded by swirling rings of ejected material. But long before reaching such extremes, the acceleration would have rendered our planet uninhabitable. The redistribution of water and air would create alien conditions. The chaos in weather patterns would break down familiar climate systems. The breakdown of ecological relationships would eliminate the connections that sustain life. These would create conditions that no complex life could survive. The Earth would become an alien world, hostile to the very creatures that had called it home for millions of years. As we consider this possibility, we gain a deeper appreciation for the remarkable stability of our current situation. The 24-hour day that governs our sleep and waking depends on our planet's perfect spin. The predictable seasons that guide our agriculture exist because of this steady rotation. The steady climate patterns that support diverse ecosystems all depend upon our planet maintaining its current rate of rotation. This stability is not guaranteed forever. The Moon, through its gravitational pull on Earth's tidal bulges, is gradually slowing our planet's rotation. Each day grows longer by about 1.7 milliseconds per century. Billions of years from now, if the Sun doesn't expand to engulf our planet first, Earth and the Moon will become tidally locked. Each day would last about what is now a month. For now, though, we live in a moment of perfect balance. As you go about your day, remember that you're riding on a planet spinning at just the right speed to sustain the intricate dance of life. The morning sunrise that greets you exists because our world turns at precisely the right pace. The evening stars that bid you good night shine down on a planet in perfect rotation. All the countless moments in between exist because we turn through space with the steady rhythm that has defined existence on Earth for as long as life has called this place home.